Torres, Polly Timblin, and I'm doing my Chapter 4 test corrections. I'll be starting with number 3. 13-foot ladder is leaning against the wall. The ladder is moving away at a rate of 1/4 feet per second. Find a rate per second at which the ladder is heading down when the ladder is 5 feet from the wall. So first, let's draw a visual. Visuals are always good. So this is the ladder itself, which is 13 feet. And then the ladder is 5 feet away from the wall, and there's the wall. So it's going to be 5. Then you're going to have to use Pythagorean theorem to figure out the length of the wall. So 5 squared plus y squared equals 13 squared, which would be 25 plus y squared, which is 159. Subtract over 25, that would be 144 plus y squared, and y will equal 12. This is 12. Now we're going to have to use the same formula as we used here, the x squared plus y squared equals z squared. But the difference is you're going to have to find the derivative. So it's going to be 2x dx dt plus 2y dy dt equals 2z dz dt. Now we're just going to plug and check. So 2 times, this is x, because if you have it on the graph, it's going to be along the x-axis. This is y, and this is z. So 2 times x, this is 5, and then they gave us dx dt when they gave us the 1/4 feet per second. So 1/4 plus 2 times 12 dy dt, which would equal to 13, which is z, times 0, because the dz dt, the rate of the ladder doesn't change, so it's just going to be 0. And then it's going to be 1, it's going to be 2, so it's going to be 5 halves plus 2, 24 dy dt equals 0. Subtract over the 5 halves, 24 dy dt equals negative 5 halves. Divide over 24, dy dt equals negative 5 over 48 feet per second. And that is the final answer.
2.
Hi, again, we will be going on to number 4. If f of x equals integral x cubed and then 0, cosine of t dt, then find derivative of f of x. So we are going to use f prime of x equals df over du times du over dx. And then it's going to be d du times f of x du dx. And they give you the f of x, so it's going to be this equation right there. So we're going to substitute it in, d du times integral x cubed 0 cosine t dt du dx. And then d du, we're going to set this, the x cubed, to u. So u equals 0, or u means 0, cosine t dt du dt. Then we're going to go on. We're going to have t u here, and we're going to times it by the derivative of the x cubed here. So it'll be 3x squared And then for the u, you're going to sub back in what we said originally, or before the u, which would be the x cubed times 3x squared. And that is the answer. Hi, and now we're going back to, or on to number 5. Use trapezoid rule with n equals 3 sub-interval to approximate using the error formula for trapezoid rule. And then our formula is integral 3, 1, 9 minus x squared dx. First thing we're going to do, we're going to have 3, 1, 9 minus x squared dx, and we're going to use integration. And this would be 9x minus x cubed over 3, 1. Now we're going to find the first derivative of this formula, the 9 minus x squared. So the first derivative is going to be, so this is 0 minus 2x. And then the second derivative, this is 0, so it's practically gone. So it really just leaves us with a negative 2x, which the second derivative of that would just be negative 2. Now the error formula, e equals to b minus a cubed over 12n squared times the mass of absolute value of f, second derivative of f, from a and b, and that's the interval. So we're just going to plug and chug. So the b, this is equal to b, and this is equal to a. So this is going to be 3 minus 1 cubed over 12, and they gave us the n in the beginning up here. They said n is equal to 3. It's going to be 3 squared times. We found the second derivative, which was negative 2. So absolute value is negative 2. And that's going to be, so that's going to be 2 cubed, which is going to be 8 over 12 times 9 times 2, because absolute value. So since it's negative, absolute value of it, it's going to be positive 2. And then we're just going to simplify. So this goes away because this can turn into a 6. And then the 8 and the 6, this could be 4, this can be a 3. So the final answer is going to be 4 over 27. And then number 5 is complete.
2.
Okay, on to number 6. Let velocity t equals to 3t squared minus 8t. The velocity of a particle moving along the x-axis for time t, and then t is greater than or equal to 0 when t equals 0. Particle is at x equals negative 4. So, first we're going to have vt equals the integral. And for a, it says determine position of particle at time t. So dt, integration sign of 3t squared minus 8t dt. And that is just going to be 3 times t cubed, because for integration, we're trying to get it the step above. So you add the plus 1 to the degree, and then whatever that degree is, you divide it by that. And then minus 8 times squared over 2, which would be t cubed minus 4t squared. And then we're going to have ft, because ft is the integral of velocity. So it's going to be ft equals t cubed minus 4t squared, which is what we found right there. Now, plus c, don't forget your calcium, or your cat, whatever you prefer. And we're going to try to solve for c. And so, they gave us the negative 4 up here. To be negative 4, it's going to set equal to the t cubed minus 4t squared plus c. And then for the t, we're just going to plug in 0. So 0 cubed minus 4 times 0 squared plus c. So c is just going to be negative 4. And then for the position as a whole, it's going to be s cubed equals t cubed minus 4t squared minus 4. And that is the answer. That's the position. And then for part C, find distance in first 6 seconds. Simple. All you're going to do, plug in 6, the st. So it's going to be s, plug in 6 for t, equals 6 cubed minus 4, 6 squared minus 4, which, let me check my handy dandy calculator here. That's going to be